In this video, we're going to calculate the velocities between two particles, one of which is stationary and the other one is moving in some velocity. Firstly, this is a positive value, so it's moving right, and this is stationary, this mass B. So remember, if this is positive, it is going right. If it's negative, it will be going left. And this is stationary. So what I always do is draw it out. So you're going to have MA and U in some direction. We're going to have MB, which is going to be 0. And then after the collision, you're going to have MA and MB here. And they're going to be some velocity of VA and VB. So we can create one equation, which is UMA, so the velocity times the mass, plus MB0 is equal to VA plus VB MB. So we have this one equation, but it's not going to be enough for us to be able to calculate the velocities afterwards. So we have Newton's law of restitution, which describes how two bodies behave during a collision. It looks at the relationship between the relative speed after the collision and the relative speed before the collision. The equation is E equals the relative speed after the collision, v2 minus v1, divided by the speed before the collision, which is going to be u1 minus u2. So we can now rearrange this and plug in our values. So we know that u2's speed is 0, so you're going to get vb minus va, which is equal to e u1 minus 0, which is the same as vb minus va equals e u1. We now have enough variables to plug in to here. So let's say this is equation 2 and equation 1 to now get an equation for VB and for VA. So let's plug 2 into 1. So we'll rearrange 2 so that it says VB equals EU1 plus VA. So if we're plugging that in to here, you're going to get U1 MA equals VA MA plus EU1 plus VA MB. So I've just plugged that in here, VB into here, into this equation here. So let's rearrange. We want to get VA by itself. So I should get U1 MA, which is going to be VA MA plus MB plus EU1 MB. We can now subtract this on both sides, so we can move it to the left-hand side, and then divide both sides by MA plus MB, so we can get VA by itself. So we're going to get VA equals U1 MA minus EU1 MB divided by MA plus MB, and then this can be cleaned up to look like U1 MA minus MB, ran out of paper, and MA plus MB. So yeah, that's EMB. Sorry about that. And now we've got our first velocity. So if these had real values, we would have the answer for the velocity after and after the collision. Now we need to find out what the velocity of VB is. And to do that, we would rearrange this. So we would get VA equals VB minus EU1 and plug that into this equation. So if we plug it in, we're going to get U1MA, which equals VB minus EU1 MA plus VB MB. So we've plugged that in here. Now again, we want to rearrange so that the VBs are on one side. So we're going to expand this firstly, and then we will subtract and divide on both sides. So if we do that, we should get VB equals U1 MA plus EU1 MA over MA plus MB. We can now simplify because we've got U1s and MAs in both. So you're going to get VB equals U1 MA 1 plus E divided by MA plus MB. And so now you've got the formulas for VA and VB when you have these two collisions. The key is to create this formula and then to remember this formula, rearrange and substitute in. I'm now going to do another video that's going to probably either be linked in the description or on the mechanics playlist, where I'll have real values and we'll use exactly this.